I am still in my variance worksheet. And as you've seen in the last video, we have a relatively straightforward basic pattern that we use with the variance worksheet. We build out our variance set. We turn variance on or off using the active variant column, that column D in the variance worksheet. And then we link those various inputs out to the various parts of the PHPP. And that's fine. We can absolutely use the variance worksheet exactly the way that we have seen in the last video. However, it's also true that the folks who made the PHPP have actually set up quite a few things inside of the PHPP to allow us to use the variance worksheet in an easier fashion. And the ventilation worksheet is, again, a good example. So let me shift from the variance worksheet over to the ventilation worksheet, and let's take a look. So I'm in my ventilation worksheet here, and as you've seen before, we are currently, as you can see here, we are currently controlling our ventilation type and our tested ACH all from the variance worksheet. And that's fine. We have these cells linked directly back to the variance worksheet. We had to set up that link, and that's all fine. But the ventilation worksheet and many other worksheets in the PHPP have some presets that allow us to work with the variance worksheet. If you notice, over on the left-hand side in column C, we actually have this variance text in the upper left corner. We also, if you notice, have a little plus icon here in the upper left corner. And what this means is if we were to press this little plus icon, we would get a rollout here, and we'll have some information regarding the variance. Now, to press this little plus icon, I have to first come down here to ventilation, right-click, and say unprotect the worksheet. So remember, to use these little plus icons, you always have to unprotect the worksheet. Notice the little lock goes away. So now if I come up here and I press this little plus button, I get this new category, this new column, column D. So what's happening here? I get these kind of grayish cells. So what's happening? Well, what's happening is, if you notice here, the PHPP is actually set up to already read back to the variance worksheet. And so what that means in practice is that for all of these cells, rather than coming into the cell and linking it back to the variance worksheet, what I can actually do is just say equals this cell right here. And I can do the same thing down here. I can just say equals this cell right here. So the PHPP, for all of these built-in variance inputs, is already set up with a column D on various different worksheets. And if you go to other worksheets, you'll find a similar little rollout. So this variance worksheet, or this variance rollout, is present on many different worksheets. So for instance, if we were to go to the Windows rollout, you'll notice that it also has a little variance rollout. And if I click that, you'll notice I get a little variance worksheet here. And what that means in practice is that many, many parts of the PHPP are already linked back to the variance worksheet. And so we don't have to do a ton of really complicated linking. A lot of it is already set up. And so we can just easily come in here, grab the cell we want, and link it right over to this guy here. Now, one thing to note is that down here, our user determined, these are not set up in the same way. So our user determined elements, those we still have to make explicit links out in the PHPP. But for all of the elements which are preloaded, summer ventilation, windows, thermal bridges, those can all be set up using this little variance column here. So that's really handy. That's really nice that that's all built in. Now, one workflow recommendation that I can make to you is anytime that you do set up a cell to be a referenced cell, to be a linked cell, what I like to do is give it this type of styling. And you can inherit this type of styling by clicking this cell, coming up to a little paintbrush, and then coming over. Whoops, missed it. Was close. Click on this cell, coming up to the paintbrush, and then coming over and clicking this. And notice that it gives it that like grayish with red instead of yellow. And that's just a that's just a best practice for your own sanity. So that when you save this file, put it away, come back to it 6 months from now, you'll remember, oh, right, that's a linked cell. That's being driven by the variance worksheet. So I'd probably do the same thing here with this guy, and that's just a visual cue to you to future you that, oh yeah, that's where that data is coming from. It's all being driven by the variance worksheet. So hopefully that basic process makes sense. Let's just look at one other example of the variance worksheet here, and then we'll take a look at one last bit of how the variance worksheet is set up. So we've looked at ventilation. That's all pretty straightforward. Let's just look at windows and shading since we were looking at windows. Let me close these, roll these up here, make some room. So let's take a look at windows and shading and see how that one works. And this one is relatively straightforward. So, well, it's not super straightforward, but it's once you kind of understand what it's asking for, it makes sense. So here we can give a name. Let's say this is window, I don't know, type 1. And over here we have the ability to select different glazing and frame types. So for instance, if we wanted a variant set here with low gain glass, and then we wanted another variant with high gain glass, I can set up those two variants. So let's change this. We'll call this low gain, and we'll call this one high gain. High gain. So we can set up those two different ones, and then let me just, for sanity, I guess let me just turn these basically off. I'll just turn that one to 1, and then I'm going to go to my ventilation as well, and I'll just set these to the same thing so that we kind of isolate our change here. So same, that means as I change between variants, you're not going to see any effect on the total performance. So the only change between the variants now is this change in the type of glass. So now I can go between low gain and high gain. Well, again, how does that information propagate out into our actual PHPP? Well, if I go to the Windows worksheet, over here, the way that this one works is I have to say what type of window do I want. Here I've got window type 1, and notice when I do that, I get this glazing shows up here. And if I just propagate that down, whoops, we don't want it like that. Propagate that down. There we go. Notice that low gain glass pops up in all of them. And if I was to come over here and I was to change the active variant to high gain, notice that this changes to high gain glass. But as with before, this bit is not actually linked into our PHPP yet. Notice that our PHPP is still using the same single pane. So what we need to do is we need to come over here. I need to now turn this into a link. So I type equals, and I come here, and I hit enter. And what I can do is I can propagate that down, and Excel is smart enough to increment the formula each time. So each one of these, each one of these formulas is linked to its same row. So here now everybody's getting high gain glass. I can come back here. I can change to low. Now everybody's getting low gain glass. And so we could see what the impact there is on our total performance here as I switch from low gain to high gain. Notice our cooling goes up, our heating goes down. So this is a way that we can make global changes to the whole PHPP, and we can test different sets of input parameters in just that manner. And as I said, that basic pattern is exactly how you're going to work with any of this. You can control basically the whole PHPP from this variance worksheet. Now, in practice, I would say the most typical way that we work with this is that we start with something that we would call, code minimum. And maybe we would apply code minimum windows, ventilation systems, R values. Then maybe we would say improved envelope. Then maybe we would do another one, which was improved ventilation system, ventilation. And then maybe we would do more and others and others. We would sort of go through, change that again. We would go through and change one element at a time, recording its impact, recording its improvement. Now, how do we do that? How do we actually record the improvement, the change? So you notice here, as I change between variants, the results get lost. So how do we actually record those results? Well, the way that we have it set up right now is we just have to copy and paste those. So let me maybe change this back. This was low gain, and this was high gain. So let's say that we want to record this performance. We want to easily be able to compare one to another. So the way that I would do that, the way that we have it set up right now, is I would just come in here, I would grab this, I would say copy, I would come over to the low gain column, and I would say paste special values. There we go. Then I would change to another variant. So I would change from low gain to high gain. I would come over here, I would say copy, I would come here, I would say paste, I would paste the values. And now we have a little data table here that shows us the impact of the different pieces, the different elements there. Notice that cooling demand went from 3.6 up to 4.5. Our heating went from 2.6 down to 1.4. But notice that our primary energy actually went down a tiny bit. So we can assess the impact of all of those different elements. Now, there is some built-in analytics here. If we come over to the right-hand side, you'll see that there is this evaluation chart. Let me turn off my frozen cells so that we can see this. If we come over here, we do have this little chart that allows us to see the impacts. So we can say, show me cooling and dehumidification demand between low gain and high gain. And we get some results here plotted. So notice that my low gain windows had a lower cooling energy demand. My high gain glass has results in a higher cooling and dehumidification energy demand, as you would expect. And of course, if we had more variants, we could plot more variants. We can sort of plot them all here. So that's really handy. We're able to record that information using that copy and paste technique. Now, let me finish up by shifting gears a little bit and talking about another way that the PHPP is actually set up to work in a more automatic fashion using this variance worksheet. So let me close this PHPP. So I'm going to go ahead and close this PHPP. And I'll close this. I'm going to not save it because we were just monkeying around. I'm going to not save it. And And instead, what I'm going to do is I'm going to load up. Sometimes when you have multiple windows open, Excel really gets unhappy. Instead, what I'm going to do is I'm going to come and I'm going to open up another type of PHPP. All right, so let me open up my PHPP folder. Let me bring that in. Now, what is this folder? Well, this is the set of files that you would have gotten when you bought the PHPP. So hopefully this looks familiar. This is what you get when you purchase the PHPP. You get a series of folders. You get some README files, etc., etc. You get your registration, all that stuff. Now, to date, so far, we have entirely been working with this file right here. This is our blank PHPP. If I was to open this up and load this up, this is our empty blank PHPP. This is the PHPP that we started this entire session with, this entire series of videos. So once this opens up, you'll see that this is just the old-fashioned blank PHPP. And there's our PHPP. So as we see, it's all blank, right? This is the original PHPP. We don't want to ever touch this one. And every time that we start a new project, we make a copy of this file, then we can start editing it. So let me close that. So that's the basic PHPP that we have been working with this whole time. However, there are other versions of the PHPP in this folder set. So if I close this O1 PHPP, and instead I go to this O2 variance PHPP, I get a different version of the PHPP. And let me show this by opening up this example. This is a completed example PHPP. So let me open this one up, and it'll be most obvious when this guy opens up and we can really take a look at this one. So once that opens up, let me pull that in. Here's the PHPP. So PHPP 9.7 variants example. So this is just an example of a completed PHPP using this alternative format. Let me try and make it a little bigger here so that we can all see. And how is this one different? Well, first of all, it has the variance worksheet exposed by default. So if I click on the variance worksheet here, notice that the variance worksheet is being used, and notice this example file has many more variants, and we can switch between those different variants. So they have an existing building, so must be a retrofit. They have a improved windows variant, a improved roof and ceiling insulation variant, an improved external wall insulation variant, a hey, let's add a heat pump variant, and then a full passive house variant that actually gets all the way to certification. So they've got 6 different variants in here. We can switch between them. Notice also that they've got all their data plotted here. So if we were to come over to the right, notice that their little graph is a little bit more interesting than the one we were looking at before, because they've got 6 different variants here. So that's all well and good. So this is looks a little bit different. But what is it that's really different about this variance format? Well, what's different in the variance version of the PHPP is that rather than having to do that copy-paste maneuver that I showed you just a minute ago, this whole section is what's known as a data table. If you notice in the link up here, it kind of confusingly says curly bracket equals table curly bracket D9 comma curly bracket. So that might be a little weird if you're not familiar with data tables. That's just a specific type of function and feature that Excel has built into it. And the long and short of it is that any time that we change anything, this entire data table is going to update. And so what that means in practice, if I unprotect and I just make this a little smaller so that we can kind of see this a little better, zoom in here. What that means in practice is that every time I make a change, so if I come to ventilation and I change some parameter, the entire data table updates. So for instance, right now we have a heating demand for our existing variant of 104, a heating load of 45. If I come down and I change the tested air change rate from 5 to 12 and just hit enter, watch what happens in my data table up here. It's going to take a minute. It'll go off and do some thinking. And now this changed to 57 and this changed to 119. Notice I didn't do any copying and pasting in this method. Here, every single time that I make a change to the PHPP, the entire data table updates. Now that's nice. We don't have to do any copying and pasting. But the downside is that it operates just as slowly as you just saw. So every single time I change any value anywhere in the PHPP, the entire thing recalculates. And what that means, at least for me on my computer, is that it's unusably slow. Now you can, and if you want to use this version, you can turn off that automatic calculation. And I think if your computer is anything like mine, that you would have to in order to actually use this worksheet in a useful way. Otherwise, it's unusably slow. So the way that you would turn off that automatic calculation is you would come up here to Formulas, come over to Calculation Options, and you would either set it to Manual or you would set it to this automatic calculation except for data tables. And what that means in Excel parlance is, yeah, do the normal calculation thing, but don't try and recalculate all the data tables. So if I do that, and I switch it over to automatic, now notice I'm on automatic except for data tables. Now if I come down here and I set this to a new value, notice it's back to like normal Excel speed. I don't have to wait 5 seconds, but also notice that nothing is updating as I change this. Nothing up here is updating. Now, every time I want to update the data table, I have to come over here and I have to hit this Calculate Now button, and then it'll go off and do the whole calculation, and notice it takes 3-4 seconds to calculate. So if I change this to 34, notice nothing has changed until I come up here and hit Calculate Now, and then it'll go off and do all the calculations, and notice everything here updated now. So if you're going to use this variance worksheet, either use a super powerful computer with a lot of RAM, or turn your calculation options to automatic except for data tables, or manual calculation. But that said, this is a great worksheet, or it's a great version of the PHPP, which has a bunch of this variance functionality built in. So if you're going to be doing a lot of variance, this might be an interesting thing to experiment with. I'll be honest though, for 99.999% of the projects that we do, we just use the typical PHPP, and then I physically set up the various links that I want to control from the variance worksheet, and then I just do a simple copy paste. For my workflow, that works just fine. For your workflow, maybe not. Maybe you want to use the variance worksheet. By all means, you have it as part of your PHPP that you purchased. This is just another type of PHPP that you can open and use at any time to build out your PHPP models. So hopefully that gives you a pretty good window into the types of things you can do with the variance worksheet. I think we should cut this one off here. Hopefully that's pretty obvious. Obviously, lots and lots of different ways that you could utilize this. There's a tremendous amount of flexibility here. It all follows that basic pattern where you set up the variant inputs, change between them, and then record those results. So when we come back in the next series of videos, we will shift gears a little bit and turn away from the Excel model itself and start to look at some other software packages that we can use to help us build better PHPP models. We'll start by taking a look at the Design PH plugin. So when we come back, we will look at a SketchUp plugin that allows us to do 3D modeling and how we push all that data back to our PHPP.